Hello everyone, I'm back with a little bit more with the unit circle. When we concluded the last video, we had just finished filling out one version of the unit circle and recognizing the big idea here is that any point on the unit circle, for theta, the x-coordinate is cosine of theta, the y-coordinate is sine of theta. So what we're going to do now is some practice evaluating some trig functions using the unit circle. One method for doing these problems is you have this circle memorized, and you can, if I say what is sine of 4 pi over 3, you know it's negative root 3 over 2. Now, not likely this year you're going to have that memorized. So I'm going to show you a couple other ways that you can do it. One, I'm going to refer back to this unit circle, and then I'll show you a second way using reference angles that you could do these problems. So here are the first 3 problems I'd like to try. Cosine of 7 pi over 6 for number 1, 2 secant of pi over 5 pi over 3, 3 tangent of 5 pi over 4. So cosine of 7 pi over 6. In your head, if you want to convert that to degrees real quick and know that that's cosine of 210 degrees, the way I do that quickly in my head is I know pi is 180 degrees. Remember, 1 pi radian or pi radians is 180 degrees. 180 divided by 6 is 30. 30 times 7 is 210. If you need to do that conversion real quick. So this is as simple as cosine of 7 pi over 6. 210 degrees, 7 pi over 6, cosine is the x-coordinate. So it is negative root 3 over 2. Now, let's say you don't have this memorized. Let me show you how to kind of build your own circle and use reference angles to do these problems. So what I would do for this one, cosine of 7 pi over 6, 210 degrees, so that puts my point right here. And I know that this is 30 degrees, and this is what I would call my reference angle. It's the angle that I make with the x-axis. And now, if I know that's a 30-degree angle, then I know my short side would be the 1/2, but it's in the third quadrant, so this is negative 1/2. The x value is the long side of the triangle, which is root 3 over 2, but again, we're in the third quadrant, so it's negative. We know the hypotenuse on the unit circle is always 1, and so cosine is x, or adjacent over the hypotenuse, so negative root 3 over 2. So when I give you these problems, a lot of times I'll have these circles in there for the work for you to put to figure these out if you don't just look at the unit circle, if you don't have that memorized. Number 2, secant of 5 pi over 3. So 5 pi over 3, quickly to do it, pi is 180, pi divided by 3 is 60 degrees, 60 divided by 5 is 300 degrees. So I go to 300 degrees, and now secant is the reciprocal of cosine. Cosine is 1/2, so secant's the reciprocal of that, which would be 2 over 1. Let me again show you using drawing my own picture how I would do that and use reference angles. So for this one, secant 5 pi over 3 is 300 degrees. So we know this is 90, 180, 270. So that means I'm right here. And if this is, that means I've got 90, 180, 270, 30 more to get to 300, which means my reference angle is going to be 60 degrees in this case. So 60 degrees. So anytime I build a triangle, the reference angle is the angle I make with the x-axis. Now, my short side in a 30, 60, 90 right triangle is the 1/2. It's positive because it's the x value. My y value is negative root 3 over 2. And then I have 1 for the value of the hypotenuse. So again, secant is the reciprocal of cosine. We can easily see cosine is 1/2. The reciprocal of 1/2 is 2. Tangent of 5 pi over 4. So I'm going to do this one without even looking back at the unit circle. So remember our pi over 4s. This went 1 pi over 4, 3 pi over 4, So here is 5 pi over 4. So 5 pi over 4 puts us in the third quadrant. We know that 4 pi over 4, this is a 45-degree angle, and in those the value is the same for x and y, root 2 over 2, and since we're in the third quadrant, they're both negative. So now tangent is the opposite over adjacent, y over x, sine over cosine, and if I take anything divided by itself, we get tangent to be 1. So what I would like you to try now is get them all on the screen here for you to see. Here are 6 problems for you to try. So pause the video, write these down, and try these problems. Now, here's a hint for 5 through 9. Those angles aren't on the unit circle, like 510 is greater than 360. So then use coterminal angles. Remember that 510 is coterminal. So 510 is coterminal. Remember, if I subtract 360, I would get 150. So cosine of 510 is the same thing as finding cosine of 150. That's your hint for that one. And that's why we spent that time in the first part on coterminal angles. So try these 6 problems. When you're done, unpause the video and I will go through each of the solutions. All right, let's see how you did. For each of these, I'm going to do them building reference triangles. So 2 pi over 3. Pi over 3 is 180 over 3 is 60. 60 times 2 is 120. So that puts the triangle right here, which means my reference angle that I'm going to use is 60 degrees. And now I have the short leg is 1/2, but it's in the second quadrant, so the x value is going negative. The long leg is root 3 over 2, and so sine is the y value, which is root 3 over 2. For number 5, I explained how we use coterminal angles to see that we're just looking at 150 degrees. So if I rotate 90 and another 60, I'm at 150. Which means my reference angle is 30. This now is the long leg. It's negative though, because we're going to the left, so negative root 3 over 2. The short leg's positive 1/2. I want cosine, which is the x value, so negative root 3 over 2. Number 6, secant of negative 210. Well, remember, in order to find coterminal angles, if it's negative, I just add 360. So if I add 360 to negative 210, I'm at 150. So I'm going to use the same picture that I used for number 5. And now I'm doing secant, which is the reciprocal of cosine, and we just found cosine is negative root 3 over 2. So that means secant is going to be negative 2 over root 3. But then I'm going to rationalize by multiplying top and bottom by root 3 over root 3. So we get negative 2 root 3 over 3. Number 7, 13 pi over 6. So I need to find my coterminal angle. So I'm going to do some work here for that. So if I have 13 pi over 6, remember it's 360 degrees away from my coterminal angles, which in terms of radians is 2 pi. So I'm going to subtract 2 pi from this, which is 12 pi over 6, which gives me pi over 6. So tangent of 13 pi over 6 is the same thing as finding tangent of pi over 6. So I'm going to draw my circle. Pi over 6 is 30 degrees. So that means I have my long leg is root 3 over 2. My short leg is 1/2. So tangent is y over x. So I have 1/2. So let me write this here. Tangent of pi over 6 is 1/2 divided by root 3 over 2. So if I multiply top and bottom by 2 over 2, I get 1 over root 3, and now I'm going to rationalize. So I get tangent of pi over 6 to be root 3 over 3. The values on the unit circle should be rationalized. Other times when we're doing trig problems and you get like 21 over root 5, sometimes I'll say you don't need to rationalize, but the unit circle values, you should get used to seeing that those are rationalized. And at the end, we'll do something so you can see the values of tangent if there's time left on this video. Cosecant of negative 2 pi over 3. So again, I'm going to do my coterminal work. So negative 2 pi over 3 plus 2 pi would be 6 pi over 3. So this is the same thing as 4 pi over 3. So now I'm really finding what is cosecant of 4 pi over 3. So I will draw my circle. Again, you could refer to the circle above if you want the one that we've completed already. Pi divided by 3, 180 divided by 3 is 60. 60 times 4 is 240. That puts my angle right here, where this is a 60-degree reference angle. So both of these are negative, so negative root 3 over 2 and negative 1/2. So cosecant's the reciprocal of sine. So I've got the reciprocal of root 3 over 2, so negative 2 over root 3, rationalize, and I get negative 2 root 3 over 3. And then the last one, cotangent of 11 pi over 4. So my coterminal angle is 11 pi over 4 minus 2 pi, which would be 8 pi over 4, so 3 pi over 4. So I'm trying to find cotangent of 3 pi over 4. Draw my picture. And 3 pi over 4, this is 1 pi over 4. Here's 3 pi over 4. At that value, we have the x is negative root 2 over 2. The y is positive root 2 over 2. Cotangent is x over y. So something that's negative divided by itself, which is positive, we get that value is negative 1. So I hope you were able to get a few of those. Now the last thing I want to show you is the values of tangent. And this is a way so that you don't have to always do the calculation like I did in problem 7. If we think of tangent as being y over x, so right here we have, if I were to write the points, we have root 3 over 2, 1/2. Here we have root 2 over root 2, but root 2 over 2 for both, and 1/2 root 3 over 2. Now remember, tangent is the y value over the x value. Well, if I take y over x, really what that is, if I think about drawing my line, that is the slope, right? Y over x would be change in y over change in x would be the slope. So I'm going to calculate these one time. So if I do 1 over 1/2 divided by root 3 over 2, this is the one we did earlier, which we get 1 over root 3, which is root 3 over 3. If I were to do this line, well, that line has a slope of 1, right? Root 2 over 2. And if I were to do this third line, well, that would be root 3 over 2 over 1/2 multiplied by 2 over 2, I get root 3. So these are the values that are going to be used for tangent. And notice the steeper line is root 3, then we have 1, then we have root 3 over 3. So if I'm comparing these slopes, this slope is flatter, so this has to be the root 3 over 3. This one's always 1, this one's root 3. So if you can think of building those around, you also have the tangent values for theta as you go around the unit circle. I hope you feel like you have a good introduction now to this. Your homework will involve practicing this quite a bit, and then next block we'll do a little bit more with the unit circle. Take care.